OTDR is an extremely useful measurement for fiber optical networks. If you want to find out how it works and why it is so useful, stick around and we'll check it out. OTDR stands for Optical Time Domain Reflectometer, and it's a measurement method that is used for various different applications. You can use it to characterize a new fiber link, locate faults and breaks, or measure distances to events within a fiber. You can use it to evaluate splice and connector quality, and you can also use it to monitor fiber health over time or test and troubleshoot FTTH and PON networks. So the question is, how does an OTDR work? Well, simply put, what an OTDR does is it sends short laser pulses into the fiber, and at the same time it measures that tiny little bit of light that is being reflected back. And it does that in two ways. Number one, it measures the power level of the reflected light, and also it measures how long the light needs to be reflected back. And because of that, the OTDR measurement can tell us quite a bit about the fiber. Number one, it can tell us how long the fiber is, what the attenuation is of the fiber. It can tell us about the events like a connector, a splice, a micro bend, or even a crack in the fiber. And because of the time measurement, it can then not only tell us that there is a crack or a bend or a connector, but it can also tell us whereabouts or at what distance in the fiber those are. Now, since all these measurements have got a lot to do with the characteristics of a fiber, we need to enter certain information into the OTDR measurement device before we get started. So in other words, we need to say what type of fiber we're measuring, what the refractive index is, and the backscatter coefficient. Both of those can be found in the datasheet of the fiber. And also we need to put in what the estimated length of the fiber is that we're going to be measuring. Now, once we've done all that and we've started the measurement, we'll get a readout which will look a little bit like this. Now, keep in mind what we're seeing here is the measurement of the reflected light. Now, on the y-axis, we've got the optical power of the reflected light, and on the x-axis is the time that the light needs to be reflected back. Fortunately, the OTDR converts the time automatically into distance, because otherwise we would have to do that. So this graph that you're seeing is a very simplistic setup, because it's basically OTDR and just a long fiber with an open end. And what you then see here is we've got the launch peak there, we've got a continuous reduction in power, and at the end we've got another peak here, and that is the open-ended fiber, because here at the fiber the more light is being reflected, and then we end up with noise, and here you will see at what distance the open end is, so that will tell us how long the fiber is. Now the question is, what is this? So why are we seeing this reflected light here? And that is the normal backscatter of the light in the fiber, so also known as the Rayleigh scattering. So in other words, the light being reflected back from impurities within the fiber. But the good thing is, this actually then shows us the attenuation of the fiber over the distance. So now let's add some events. A connector will look a little bit like this. So we have a peak of reflection, so because we've got more light being reflected from the connector, and then it dips down and continues at a lower level, because obviously the connector introduces attenuation. A splice, a fusion splice, will look a bit like this. So we don't have a peak, but we just dip down. Now a crack would look a little bit like that, which is very similar to a connector. And a micro bend will look a little bit like this, so which is also very similar to a splice. So how do we distinguish between these different things? I mean, connector, good. Crack, not so good. So it is important to be able to do that. But if I go into the details about how you distinguish between them exactly, this wouldn't be a brain snack video, it would be a brain snack 5-course meal video. So, but to give you an idea, there are so many things that you can adjust and tweak with the OTDR measurement. And each one of those adjustments will result in slightly different readouts here, which will help you distinguish between them. So you can adjust the pulse length, you can change the resolution of the measurement, and also change the average sampling of the measurement. But a very common thing that is done, and not only just to distinguish between the different events, but also depending on what you're measuring, you use different wavelengths. Because if you're going to qualify a new fiber link, you'll probably use 1310 or 1550. If you want to see if you're looking at a bend or a splice, then at some point you also use 1550 or 1625 to see that, because at that wavelength we get a different readout for a bend. Or if you're monitoring live traffic or live fiber, then you use 1625 or 1650. Now, as you can see, an OTDR measurement is pretty much a science in itself, and it does require quite a bit of experience to be able to do the measurement and to get a good and qualified readout from the measurement. But still, it's a very important measurement. So, I hope you enjoyed this video and that you learned something today. If so, please leave a comment. And of course, remember to follow our channel so you get your regular dose of brain snack. Until next time, bye-bye.